So have you ever seen those sort of slow, wrinkly patterns in really cold ground, like up in the Arctic?
Oh, yeah, those kind of wavy shapes. Solifluction lobes, we call them.
Right, exactly.
Yeah.
Well, turns out scientists are seeing something that looks surprisingly similar on Mars.
Yeah, it's pretty fascinating. We've got this high-resolution orbiter data, and it shows these wave-like features in, I think, 9 different craters up there.
9 craters. And they look just like the ones on Earth.
They look remarkably like them, yeah.
Yeah.
Which is, kind of puzzling.
How so? I mean, similar shapes.
Well, think about it. Earth's Arctic has this seasonal freeze-thaw cycle, right?
Right.
Water melts, the ground gets soggy, it slowly creeps downhill, making those lobes.
Okay, yeah, that makes sense. Water's the key.
Exactly. But Mars, it's a frozen desert. We don't really expect the same kind of surface water activity, at least not now.
Right, it's incredibly cold and dry. So how could Mars possibly get these same geological fingerprints? What's the thinking?
The leading hypothesis involves something called sublimation.
Sublimation. That's where ice turns straight into vapor, gas, skips the liquid state.
Precisely. The idea is that maybe subsurface ice on Mars is very, very slowly turning into water vapor.
Right.
And that subtle process, maybe the expansion and contraction as the ice vaporizes and potentially refreezes, could be just enough to make the soil creep downhill very slowly.
Wow. Okay, so a completely different mechanism, ice turning to gas instead of melting, but potentially the same result, these wavy lobes.
That's the idea, yeah. It's a way to get slow soil movement without needing liquid water flowing around on the surface.
Interesting. Now, I also saw something in the data about the size. These Martian lobes, they're not quite identical in scale, are they?
No, that's another really key piece of the puzzle. They're significantly taller. The Martian ones are about 2.6 times the height of typical solifluction lobes on Earth.
2.5 times taller. Why would that be?
Well, researchers looked at the physics of how granular stuff like soil and dust flows, granular flow physics, and it turns out the difference seems to come down to gravity. Mars has much weaker gravity than Earth.
Ah, right. Only about, 38% of Earth's gravity?
Something like that, yeah. So with less gravity pulling down, the loose Martian soil can basically pile up higher before it gets unstable and slumps.
Makes sense. It can stack steeper before collapsing.
Yeah.
So the same basic physics apply, but the different gravity changes the final shape.
Exactly. The underlying principles of how the material behaves are similar, but the environmental conditions, specifically gravity, scale the result differently.
So taking a step back then, what does finding these solifluction-like features actually tell us about Mars? What are the bigger implications?
It's potentially huge, because if these lobes are formed by some process involving subsurface ice, even sublimation,
It means there's likely ice down there, or was very recently.
yes, it strongly suggests the presence of subsurface ice in these crater regions. And that's incredibly exciting.
Why is finding subsurface ice so important for Mars exploration? I mean, we know there's ice at the poles.
True, but finding it potentially in these mid-latitude craters is different. Where you have ice, especially subsurface ice, you have the possibility, maybe, just maybe, of creating little pockets where liquid water could exist, even temporarily, perhaps melted by impacts or geothermal heat.
Ah, okay. Protected underground niches.
Exactly. And those niches, those spots with potential liquid water, even if transient, are prime locations in the hunt for past habitability.
You mean searching for signs of past life?
Precisely.
Yeah.
If Mars ever supported microbial life, areas with subsurface ice and potential meltwater would be the most likely places to look for preserved evidence. These lobed terrains could be signposts pointing to those zones.
So these frozen ripples, these subtle shapes we see from orbit, might actually be guiding us to the best spots to land future missions looking for ancient life. It really connects back to that whole question of Mars's past climate, doesn't it?
It absolutely does. It suggests a history where ice was perhaps more widespread below the surface than we might think, influencing the landscape in ways we're just starting to understand. Seeing these similar forms, shaped by similar physics despite different drivers and gravity, it just highlights how fundamental processes shape planets.
It really makes you think, doesn't it? What other surprising connections might be hiding out there, linking seemingly totally different worlds through basic physics? Something to ponder.
Definitely. The universe is full of echoes like that.